I welcome you again to this channel. Thank you for watching the video, and then I want to encourage you to subscribe and also like and share the video. Don't forget, at the end of this tutorial I will pass an important information, and then I don't want you to miss the information. Also, in the description of this video I will put my WhatsApp link there, so that for those of you who want the slide of this tutorial, you can also click on the link. I will send it to you. All right, thank you for that. So in today's video we are going to examine microscopy. This lecture is prepared based on the university standard. And for those of you who are, those who are still in secondary schools, high schools, you can also watch the video to gain 1 or 2 advanced knowledge. All right, let's dive into the video. What is microscopy? Microscopy is the scientific technique of using microscopes to observe and study objects that are too small to be seen with the unaided eye. So, next slide. Why do we use a microscope? Based on the previous definition of microscopy, you should be able to point at least 2 things, or to tell us little about the use of microscope. Many things are smaller than we can see with the unaided eye. To accurately study biology, we need a tool to help us see these tiny things. Example: bacteria, fungi, viruses. All these things, we cannot see them with our unaided eye. We need a tool called the microscope to help us see them in a magnified form. All right, next slide. History of microscope. Anthony van Leeuwenhoek is credited with developing the first microscope in about 1665. Although the compound microscope was already in use, what made Anthony's invention special was that he was able to magnify his wee beasties up to 270 times. Anthony was the first to see bacteria, red blood cells, yeast, and so much more. Okay, before I move to the next slide, in the description of this video, part of the reason why I will put my WhatsApp link is that I will also drop some likely questions that you may encounter in your test and exam. But for those of you watching the tutorial now, please take note of this name, Anthony van Leeuwenhoek. You may be asked in your test or exam, and also just master the name and the year. All right, let's move to the next slide. You can see the microscope and the picture of Anthony van. You can see it. So next slide. Classification of compound microscopes. Number 1, we have binocular compound microscope. They have 2 eye lenses with magnification of 10 times. The eye lenses, you can also call it ocular lenses. So the magnification is 10 times. But don't forget, it is very important before you start your microscopy to check the magnification of the ocular lens. It is very important so that you will not make wrong calculation. So binocular compound microscope, they are the most common in the modern laboratory. They are the most common in our lab, in our laboratory, in your school. They are the most common. They have magnification of up to 1000 times. Those are the features of compound binocular microscope. So you can see the picture of a binocular compound microscope. You can see the two ocular lenses. It has a magnification of up to 10 times. But don't forget, I said there are some that the magnification is 5 times. All right, next slide. Stereo microscope. The magnification is 10 times. They are used for the observation of large objects. Example, leaf, whole body or spider. All right, and let's look at the picture of a stereo microscope. You can see the picture of a stereo microscope and also master the similarities between a stereo microscope and a compound binocular microscope. All right, you can see that they are both of them, they have two ocular lenses with 10 times magnification. All right, so next slide. Monocular compound microscope. A monocular microscope has just one eyepiece to look through. It has just one eyepiece or ocular lens. Most students find this type of microscope more challenging to use. You can see the picture of a monocular microscope. You can see that it has just one eyepiece. Just one eyepiece. So please master the similarities or the differences between the binocular compound microscope and monocular compound microscope. All right, next slide. Electron microscopes. Objects smaller than 0.2 micrometer can be seen with an electron microscope. Example, viruses, internal cellular structures. Scanning electron microscope. In scanning electron microscope, image appears in 3 dimensions and in black and white. The magnification is usually 1000 times to 10,000 times. It is particularly useful for studying the surfaces of cells and viruses. This is a picture of scanning electron microscope. You can see. All right, next slide. You can see the image of a mosquito head up to 200 times. This is a mosquito head under scanning electron microscope. You can also see red blood cells, color enhanced. You can also see how magnified you can see the red blood cells. So we have transmission electron microscope. The item to be viewed is sliced into very thin slices. The image is a slice of the cell. These images are used to cross sections of cells and their intracellular structures. Magnification can be as much as 10,000 times to 100,000 times under transmission electron microscope. So you can see the picture of transmission electron microscope. All right, next slide. Let's look at the image formed under transmission electron microscope. You can see the sperm cross section under them. Mycobacterium tuberculosis. You can see the image formed. All right, next slide. So please, in your test and exam, this part is very important. Please take note. It's very important. Know the following microscope parts and their functions. Please note, very important. But I'm going to run through them one after the other. So I've made a separate slide for this microscope parts and functions. So if you need that too, you can click on the WhatsApp link and tell me what the material you want to collect. So I will send it to you. But it is very important that you know all these microscope parts and functions. You need it both in your exams and practicals. All right. I'm going to run through them. I will tell you the location and the function of each of these parts of microscope. All right. The first one is the eyepiece. Location: at the top of microscope body. That is the first thing you are going to see in every microscope. The eyepiece. The location is at the top of the microscope body. Function: the eyepiece, also known as the ocular lens, is the lens through which the viewer looks to observe the specimen. It typically provides a magnification of 10 times and helps in forming the primary image. We have the nose piece. Location: below the eyepiece. Function: the nose piece is a rotating mechanism that holds multiple objective lenses. It allows the user to easily switch between different objective lenses, which vary in magnification by rotating the nose piece. Objective lens. Location: attached to the nose piece. Function: objective lenses are located near the specimen and are responsible for gathering light and magnifying the image. Microscopes typically have multiple objective lenses with different magnification levels, such as the shortest among the 4 objective lenses has 4 times magnification. Then the next one, 10 times, 40 times, and 100 times, which is the longest, allowing users to view the specimen at various levels of detail. Later, we are going to talk more about objective lenses. Stage. The stage is located below the objective lenses. Function. The stage is a flat platform where the specimen is placed for observation. It typically has a central opening through which light passes to illuminate the specimen. Stage clip. The stage clip is located on the stage, and the function of the stage clips are to used to hold the specimen in place on the stage. They ensure that the specimen remains stationary and in focus during observation. Light switch. Concerning the location of the light switch, it varies depending on microscope model. But the function of the light switch controls the power supply to the microscope's light source. It allows the user to turn on or off as needed. Light intensity knob. The location of the light intensity knob also varies depending on microscope model. Function. The light intensity knob adjusts the brightness of the light source. By rotating this knob, the user can increase or decrease the intensity of light illuminating the specimen, providing optimal illumination for observation. Fine adjustment. Location. Typically located on one side of the microscope body. Function. The fine adjustment knob allows for precise focusing of the microscope. It provides small incremental changes in the position of the objective lens to achieve a sharp focus on the specimen. We have coarse adjustment. Location. Typically located on one side of the microscope body, but note it is very close to the fine adjustment knob. Alright, the function of coarse adjustment knob is used for initial focusing of the microscope. It provides larger rapid adjustment to bring the specimen into a rough focus before using the fine adjustment for fine tuning. Stage manipulator knobs. Location. Located near the stage. The function of the stage manipulator knobs control the movement of the stage in the X and Y direction. They allow for precise positioning of the specimen under the objective lens for observation. The condenser. Location. Located beneath the stage. The condenser is a lens system that focuses light from the light source onto the specimen. It enhances the resolution and clarity of the observed image by providing a concentrated and uniform light source. Light source. The light source is typically located beneath the condenser. The function. The light source provides the illumination necessary to visualize the specimen. It can be in the form of a built-in light bulb or an external light source, such as a halogen or LED light. Iris diaphragm. Iris diaphragm knob is located near the condenser. The iris diaphragm knob is an adjustable circular aperture located within the condenser. The iris diaphragm knob controls the size of the aperture, regulating the amount of light that reaches the specimen. However, adjusting the diaphragm helps achieve optimal contrast and resolution. Cord holder. Location varies depending on microscope model. The cord holder is a practical feature for holding and managing power cord of the microscope. The cord holder is a practical feature for holding and managing the power cord of the microscope. It helps prevent the cord from interfering with the user's workplace or getting tangled. Lastly, microscope body. Location. Main structure of the microscope. The function. The microscope body houses all the components of the microscope, including the optical system, stage, and controls. So these are the functions and the locations of the parts of microscope, but I will try to make an abridged version of these functions and put it in a slide. So if you need it, you can let me know. I will send it to you. All right, so let's go to the next slide. So try to study more on the part of a microscope, and also please master their functions. It is very important. All right, so let's talk about the magnification of the lenses. Next slide. Ocular lens. Like I said, the ocular lens has a magnification of 10 times. But in some microscope, you can see just try to check anytime you are having your practical or you are to use a microscope. Try to check the magnification of the ocular lens. But in most of the microscope that you will be using in your practical, I believe that the magnification will be 10 times. So please take note of this. Take note of this information. All right. So next slide. There are 4 objective lenses. Number 1, scanning objective lens. The scanning objective lens usually transmits red light. It is the smallest objective lens among all the 4 types of objective lenses that we have here. So, and also it transmits red light. Please take note of the magnification and the color of light that each of these lenses transmit. The second one is we have the low power objective lens. It usually transmits blue light and its magnification is 10 times. Most cells and microorganisms can be morphologically observed at low power objective lens, although the internal structures might not be very clear. So number 3, we have the high power objective lens. It transmits yellow light with 40 times magnification. It is also most ideal objective lens for the observation of non-stained preparations, either wet or fixed preparation. Then the last objective lens, we have the oil immersion objective lens. It transmits white light and has a magnification of 100 times. It requires the use of oil before observation, and it is the objective lens with the highest power in a regular compound microscopes. Before we move to the next slide, I want to talk a bit about the properties of each of these objective lenses. Number 1, approximate focal length. For scanning objective lens, we have the approximate focal length is 4 mm. Then for low power objective lens, we have 16 mm. For high power objective lens, we have 4 mm. Then oil immersion objective lens, we have 1.8 to 2.0 mm. Then the working distance. For scanning objective lens, we have 17 to 20 mm. Low power objective lens, we have 4 to 8 mm. Then for high power objective lens, we have 0.5 to 0.7 mm. Then for oil immersion objective lens, we have 0.1 mm. Then finally, we have approximate resolving power. For scanning objective lens, we have 2.3 micrometer. Low power objective lens, 0.9 micrometer. High power objective lens, 0.35 micrometer. Oil immersion objective lens, 0.18 micrometer. All right. So now let's move to types of microscope. Types of microscope. This I think you will need this, so I don't put that in this slide, but if you want the complete slide of this lecture, so just click on the WhatsApp link in the description. I will make everything available in the slide. All right. So types of microscope. We have light microscope. So under the light microscope, we have the bright field light microscope. We have dark field light microscope. We have phase contrast light microscope. Then we have fluorescence light microscope. Please study more on these 4 types of light microscope. All right, so let's like the total magnification. Don't forget, or please note, that the magnification of your image is the product of the ocular lens and the objective lens. The product of the ocular lens and the objective lens is equal to the total magnification. So when the image travels through the objective lens and the ocular lens, it magnifies the magnification of the objective lens by 10 times. The ocular lens, if you are viewing under 4 times objective lens, you already know that your total magnification will be 40. So don't forget the simple formula. The total magnification is equal to the product of the objective of the ocular lens and the objective lens. So just multiply the 2 numbers, then you get your total magnification. All right, so let's move to the next slide. So the proper way to carry your microscope. So you can see the image on the slide. Always carry the microscope with 2 ends, holding it close to your body. So don't carry a microscope carelessly. It is an optical instrument and very fragile. So in proper way of carrying microscope, carrying a microscope like this could result in a serious issue, and then this will not score you brownie point with your instructor. All right, next slide. Proper usage of the microscope. At the lab table, unwrap only as much cord as you need. The rest should remain stored around the cord wrap. So you can see the image in the slide, how the power cord of the microscope is wrapped. So this is how you should maintain your own microscope. The microscope should always be stored with the 4 times red lens in place and the stage in its lowest position. So after using your microscope, you should resolve the objective lens back to the shortest one, which is the 4 times magnification. So you should resolve it back to the lowest objective lens and also the stage to the lowest position. Please take note of this procedure. Always store your microscope in its numbered position with the dust cover in place. Alright, next slide. How to focus your image. Number 1, place the slide on the stage, held in place by the stage clip. Always start with the 4 times lens. This is how to get the focus of your image in microscopy. You start with the 4 times lens, then focus your image, then move to the 10 times lens, focus, then never use the coarse focus higher than 4 times. Repeat at the 40 times lens, focusing using the fine coarse adjustment. So this is just telling you that to get the focus of your image, you start with 4 times magnification of the objective lens. So after you get the focus, then you move to 40 times. So after you get it, do not touch the coarse adjustment again. Just use the fine adjustment to fine focus your image. If you raise the stage after getting your focus, you might break the slide. You might break the specimen slide. So distance between lens and slide. Use only the fine focus knob with the 40 times and 100 times lens. So you can study this more. Alright, the oil immersion lens. The oil immersion lens or 100 times lens is used with special optical oil. It makes the image clear at a higher magnification. Your instructor will tell you if you need to use this lens. It is important to remove all the oil if you use the oil immersion lens. Alright, thank you for watching the video. This is the end of today's tutorial. So I would like you to subscribe and also share the video. And also don't forget to message me if you need the material and also likely questions that you might see in your test and exam. So, and please, if God is putting it in your mind to help us to grow this channel so that we can get more equipment to get a very sound audio, so you can also click on the link to message me. All right, thank you for watching the video. Please like, share and subscribe. Goodbye.